So we use it in triangles. It's used to find unknown angles or sides, and we find it using what we call trigonometric ratios. And there's 3 of those. So before we even go into those, you do need to know how to label a triangle. And the things that you need to know about labeling a triangle is labeling the sides dependent on the angle that you're looking at. So I've got 2 triangles here, and the 3 words that we're after are the opposite side, the adjacent side, and the hypotenuse. Now, from prior knowledge, doing Pythagoras' theorem, you should know that the hypotenuse is the one that is the longest side of the triangle, and it is opposite that 90-degree angle. So we can label the hypotenuse, and that's not going to change on either of these triangles because it has to be the longest side. What will change is the opposite side and the adjacent side. Now, adjacent, the word adjacent in normal everyday life means next to. So for an adjacent side in a triangle, it's going to be the one that is next to the angle. So the angle I have labelled here as theta, and it's a Greek letter, and we use it quite a lot in maths to denote an angle. So we're looking for the side that is right next to that angle. Now you can see there's 2 sides, there's this one and this one. However, we've already labelled the hypotenuse, which means the adjacent must be this one here. And if we look at our second triangle, we're looking at these 2 because they're the 2 that are right next to that angle. But the hypotenuse is already labelled, so this one must be the adjacent. And that leaves the other side as the opposite. And that makes sense because it's across the triangle. Because if you're standing opposite somebody, you're across from them. So we can label those. It's important to understand how to label the triangles because that helps you determine which ratio you need to use. Now, onto the ratios. We've got 3 of them, and they're very unique because you have to use certain sides for certain ratios. So if we're looking at sine is our first ratio, and if you have a look at a scientific calculator, you can see the buttons on there, and on a calculator they look like sin, cos, and tan. However, that's the abbreviated word, so when we are talking about them, we should use the correct language, and in this case it is sine, not sin. So we look at sine. Sine uses, we've got sine of an angle is equal to the opposite side divided by the hypotenuse. So you can see we're using the opposite and the hypotenuse for sine. Then if we go on to cosine, we're using the adjacent and hypotenuse. Okay, so see how both of them use the hypotenuse. However, they're unique because sine uses the opposite and then cosine uses the adjacent. Then our last one is tangent. Now this is known as tan on the calculators, and tan uses the opposite and the adjacent. So if we go back to our picture, tan uses, so I'll just write here, tan is going to use the opposite and the adjacent. Then we've got sine. Sine uses the opposite and the hypotenuse. And then we have cosine, and cosine uses the adjacent and the hypotenuse. So you can see they all have a different combination of sides that we use. And that's important because we need to know which ratio we're using depending on the triangle that we've got. So we'll start with sine, and what I'm going to do is I'm going to do 3 examples of each ratio. So the first one, the first step when we're doing trigonometry questions is to always label your sides. While you're learning how to do trigonometry, it is the easiest way to make sure that you've labelled your sides and then you can choose the appropriate ratio. So if we have a look at this particular example, the angle's here, 43. And if we have a look, we've got the opposite side because that is the one that we have to go across the triangle for. And we've also got information on the hypotenuse. And then we can label our adjacent, but you can see the adjacent isn't going to help us with this particular example because there's no information on it. So we can just go, okay, we're not using the adjacent side. So it means we're using sine of theta is equal to the opposite over the hypotenuse. The next step when I'm learning how to do trigonometry is writing down what I know. So the angle is 43. The opposite side, we don't know. So I'm actually going to label that x, even though it's a question mark on the diagram. And the hypotenuse is 5.9. So then when I'm doing my question now, I've got the formula and I've got the things that I know and I can write it into the formula. So it's going to be sine of 43 is equal to x over 5.9. Now there comes some slight algebra, not a lot, but it's just working out how do we get x by itself. So at the moment we've divided by 5.9. So to get rid of that we're going to multiply. So what we do is x equals 5.9 times sine 43. And the important thing with trigonometry when you're using your scientific calculator, that your calculator has deg written at the top, or it might have a letter D. It needs to make sure, you need to make sure your calculator is in that setting, otherwise you'll get all of the answers wrong. And when I put that into my calculator, just typing it in as it is, to one decimal place, it would be 4.0. So I'm going to go to 2 decimal places. It would be 4.02 millimeters, and remembering to write our units. So that's our first example. We just wrote down what we knew, substituted it into the formula, and then rearranged. Our second example for sine. Again, label our sides. We've got the opposite. We don't know the hypotenuse, and we have the angle. Again, we can label the adjacent, but there's no information on the adjacent, so we're not going to use it. So then we write down what we know. The angle is 8, the opposite is 1, and the hypotenuse this time is x because we don't know what that is. Now we had our formula on the previous page, and we just substitute in what we know. So sine of 8 is equal to the opposite, which is 1, over x at the bottom. Can you see the difference? Here, in this first example, x was on the top and we multiplied. Here, in the second example, x is on the bottom, which means we need to do division this time. So we do 1 divided by sine 8, and you should get 7.2. 2 centimetres there, 7.2 centimetres. Our third example is a little bit different. If we have a look, we label our side. So we've got an angle here that's labelled, but we don't know what that is. We go across the triangle to get our opposite side, and then we have our hypotenuse here. So this time, it's our angle that we don't know. So our angle is x. Our opposite side is 8.5. And our hypotenuse is 9.9. We substitute in to the formula what we know. So sine of x is equal to 8.5 divided by 9.9. Now we've got a bit of an issue because it's the sine that we need to move now. And when we do this, we actually move it. When we move it over, we have to use what we call the inverse. Now, on your calculator, if you have a look, just above the sine, there should be a sign with a little -1 next to it. And that's the button that we use to work backwards. So on some calculators, you press the shift button and then you press the sign. Some, it's a second function button and you press sign. And your calculator screen should come up with something that looks like that. And then this here, our fraction means 8.5 divided by 9.9. So So we just do 8.5 divided by 9.9, which is 59 degrees. Oops. 59 degrees to the nearest whole number. Now, usually with angles, unless otherwise stated, we round to the nearest whole degree. So it's 59 degrees for that angle here. So this angle here is 59 degrees. The next lot of examples is cosine. So it works in the similar way to how sine works. So basically, if you can understand how to do one ratio, you know how to do the rest, because the working is the same. It's just different sides are used. So again, we start with labeling our sides. If we have a look at this, we know that 5.5 meters would be the hypotenuse because it's opposite the 90-degree angle. Then we have a look at the other angle that's labelled, so 42 degrees, and the question mark side is right next to it. So that must be the adjacent. And again, we could label this as opposite, but because there's no information on it, it's irrelevant, so we're ignoring that. So we know that cosine of theta is equal to the adjacent over the hypotenuse. And again, we write down what we know. The angle is 42. The adjacent this time. So notice how I'm writing it in order. So I'm writing the angle and then the adjacent and then the hypotenuse in order that way. So the adjacent we don't know. The adjacent is x and the hypotenuse is 5.5. And then from here, we just fill out what we know. So we've got cosine of 42 is equal to the adjacent, which is x, over 5.5, which is the hypotenuse. Now we get to the point where the x is on the top. And remember, if the x is on the top and we're dividing by 5.5 on the right-hand side, to move it, it's going to become multiply. So it would be 5.5 times cosine 42. Now for this example, I haven't written the multiplication sign between them. That's because you don't actually need to. We recognise that if there's no operation between two things, then it's a multiplication, and your calculator recognises that as well. So if you put that into your calculator, you should get 4.1 metres to one decimal place. So 4.1 for the first answer there. The second example, same thing, we label our sides. So we've got the adjacent side here and then the hypotenuse here. We write down the information that we know. The angle is 68. The adjacent side is 3 and the hypotenuse is the unknown this time, so I'm going to use x. Then we put it into our formula. So we've got cosine of 68 is equal to the adjacent, which is 3, divided by the hypotenuse, which is x. Now remember, when the x was on the bottom, we did division. So it becomes 3 divided by cosine of 68. And that gives us 8 centimetres. It's actually 8.008, so to one decimal place or to a whole number, it's 8 centimetres. So we'll just leave it as a whole number for that one. This next part here, again, we're looking and we've got an unknown angle this time. So we need to label our sides. The 8.5 centimetres is opposite the right angle, so that must be the hypotenuse, which makes this one here being right next to the angle, the adjacent. We write down what we know. The angle this time is x. The adjacent is 4.4 and the hypotenuse is 8.5. Then we write it in and substitute it into our formula. Cosine of x is equal to the adjacent, which is 4.4, divided by the hypotenuse, 8.5. And again, we're at that situation where it's the cosine that we need to move, which means we have to use that second function, that shift function, to get the inverse of cosine. So our working out would be cosine -1, so the inverse of cosine, and then 4.4 divided by 8.5. Remembering that that fraction line means division. And the answer is 58.8, which means we get 59 degrees as our answer. So that angle that I've circled on the diagram there is 59 degrees. Our last lot of examples in terms of just the ratios is tangent. So remember, if we think back to the start of the video, the tangent ratio is opposite divided by adjacent. So first thing is we label our sides. So this is our opposite. Notice how there's nothing along this side here now. That's the hypotenuse. And tan has nothing to do with the hypotenuse. So anytime you see a question and there's no information on the hypotenuse, you think to yourself, this is most likely going to be tan, but we still label our sides just in case. So we've got opposite and adjacent. And again, I'm going to write the formula here because it's the first example. So we've got tan of theta is equal to the opposite divided by the adjacent. We write down the information. So the angle is 51. The opposite we don't know, so that's x. Again, notice how I'm writing it in the order. And the adjacent is 5.3. So then we fill out what we know and substitute into the formula. Tan 51 is equal to x divided by 5.3 because it is opposite divided by the adjacent. And what do you know? It looks very similar to the first example of cosine and sine. The x is on the top, which means we must be doing multiplication. So it's 5.3 tan 51. And then you put that into your calculator to get 6.5 to 1 decimal place. And again, remembering to put our units. Example 2 for tan. We label again, so we've got 53 degrees as our angle. If we go directly across from the angle, which is the opposite, and then right next to it is the adjacent, again, no information along that hypotenuse there. We write down the information that we know. The angle is 53. The opposite side is 7.3. And the adjacent this time is the one that we don't know. So that's x. Next step, substitute in. Tan of 53 is equal to 7.3 opposite divided by the adjacent, which is x. Now x is on the bottom, which means we're going to do division. And you'll notice that I'm writing it as a fraction. It's totally fine to write it as with a division sign. It's just easier to think, okay, I've got to swap where the x and the tan 53 are. Put that into your calculator and you get 5.5 centimetres. The last example for this one is an angle example again, but of course it's going to be a tan, so we label our sides opposite for 2.4 and the adjacent, again, no information along that hypotenuse. Write down what we know. The angle is x because that's what we're trying to find. The opposite is 2.4 and the adjacent is 2.9. So we write in into our formula what we know. So tan of x is opposite, which is 2.4, divided by the adjacent, which is 2.9. Then, because we're trying to get rid of tan, and remember we're finding an angle, so we're going to use that shift function, that inverse of tan, to do 2.4 divided by 2.9. So inverse tan of 2.4 divided by 2.9. And that gives us 39.6. But remember, it's an angle, so we round to 40 degrees for that because we're going to the nearest degree unless it says otherwise. So 40 degrees for that angle there. So some important points to remember from those examples that we've just done. If the unknown is on the top, we multiply. So if the x is on the top of the fraction, we do multiplication to solve for it. If the x is on the bottom, we do division, just like we did for the second example of each of those. And if it's the angle that's the one that we don't know, we have to use the inverse of whatever ratio. So the inverse of sine or the inverse of cosine or the inverse of tan. We've got one more example to do, and it's just an example of a basic worded problem. So again, just like with Pythagoras' theorem or any mathematical question that's a worded problem that involves a diagram, it's best to draw it. So it says a flagpole is 7.6 meters tall and has a support wire attached to the top of the flagpole and the ground. If the wire makes a 65-degree angle with the ground, how far from the base of the flagpole is the anchor point? So, first thing, we need to draw our diagram. So we've got the flagpole here. Now we are assuming that the flagpole is at 90 degrees to the ground. We have a support wire that goes from the top of the flagpole down. Let me just try drawing that again. So, support wire down to here. We've got a right angle where the flagpole meets. We can put 7.6 meters on the flagpole side. It says the wire makes a 65-degree angle with the ground, which means it's this angle here, so that's 65 degrees. And the last piece of information that we need to put, it says how far from the base of the flagpole is the anchor point, which means this is the base of the flagpole here. This is your anchor point here. So we're looking for this side, this horizontal side here. So we've got 7.6 meters, X, and 65 degrees. Now, remember to start our question, we label our sides. So we've got the opposite because it's across from the 65 degrees. And then we have the adjacent because it's right next to it. Again, no information on the hypotenuse. Now, if there's no information on the hypotenuse, it means that we must be using tan because tan doesn't involve the hypotenuse. So we can write down our information. The angle is 65, the opposite is 7.6, and the adjacent is what we need to find out. We substitute into our formula. So tan of 65 is equal to 7.6 divided by x because it's opposite divided by adjacent. Then we remember if the x is on the bottom, we're doing division. So it's 7.6 divided by tan 65. And we get to one decimal place 3.5 meters. And then of course, because it's a worded question, we would answer with a sentence. So the anchor point is 3.5 meters from the base. And that's the worded problem finished. So in summary, we can remember the ratios by using SOHCAHTOA. And you can see I've written it in two ways here. The bottom way, this part here, is just the acronym SOHCAHTOA. The top part is written as sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. That's why they're written above one another. So that's one way you can remember it. The other way is to use the rates triangles. So when we're doing this, when we're using a rates triangle, for example, if you need to find the opposite, so the opposite's the one that you don't know how to find, you would put your hand over the opposite. Okay, so we would cover up the opposite here. I'll just blank that out for you. So we'd cover up the opposite because that's what we're trying to find. And then it would tell us that we need to do sine of the angle and then multiply it by the hypotenuse. Okay, and that works for each of those. There's the cosine rates triangle and the tan rates triangle. And you can see, if we go back to this original screen here, this is how you would write them into the rates triangle. So bottom left, top, bottom right. And then you can go from there. Hopefully you have a good understanding now of the basics of trigonometry.